Given an integer array nums and two bounds, min k and max k, count subarrays whose smallest value is exactly min k and whose largest value is exactly max k. Example 1, min k is 1 and max k is 5. Indices 0 through 2 give 1 3 5, minimum 1 and maximum 5. Indices 0 through 3 extend that block with 2, still minimum 1 and maximum 5. Those are the only two qualifying subarrays, so the answer is 2. Example 2, every entry is 1, so min k and max k both equal 1. Every contiguous subarray has minimum and maximum equal to 1. 4 elements admit 10 subarrays in total, so the answer is 10. When counting valid subarrays with fixed bounds, any number that drops strictly below our minimum or climbs strictly above our maximum acts as an absolute barrier. It is a poison element. No valid subarray can cross this position, meaning it completely resets our searchable workspace window. To count efficiently without double counting or looking back recursively, we shift our mindset. As we loop through the array, we ask ourselves a single question: if a valid subarray must end exactly at our current index I, how many valid starting positions exist to its left? To answer this question at any position, our algorithm only needs to remember 3 pieces of historical information: the index of the last seen out-of-bounds element, the most recent position of our target minimum, and the most recent position of our target maximum. For a subarray ending at our current position to be completely valid, it must satisfy 2 conditions simultaneously. It must start after the last out-of-bounds element to avoid being poisoned, and it must start at or before the leftmost target boundary so that both the minimum and maximum keys are safely trapped inside. This gives us a clean mathematical formula. The total number of valid starting positions for our current window is simply the minimum of our last seen target indices, minus our bad element index. If this calculation yields a positive number, that is exactly how many valid subarrays end at this index. What happens right after the poison element resets our window? Our minimum and maximum trackers still sit at 0 and 2, but the formula min, 0, 2, minus 4 drops below 0. We handle that cleanly by clipping the count to 0. By accumulating these individual counts at every single step, we crawl through the entire array smoothly. We update our anchors, apply our boundary formula, and pour the result straight into our grand total, resolving the problem completely in a single linear pass. We begin by initializing our environment. We set our last seen out-of-bounds pointer, our minimum key tracker, and our maximum key tracker all to -1. We also establish our grand total accumulator starting at 0. At index 0, we hit our target minimum of 1, updating min idx to 0. However, because we haven't seen our maximum key of 5 yet, max idx stays at -1. That keeps the valid starter count at 0 for these first 2 steps. At index 2, we land on our target maximum, 5. This locks max idx at 2. Now, our formula can find a valid intersection. The minimum of our target positions is 0. Subtracting our bad index of -1 gives us exactly 1 valid starting option, creating the subarray 1, 3, 5. Moving to index 3, we encounter a 2. It's safely within our limits, so no trackers change. This means the exact same starting position at index 0 remains completely valid. It stretches out to form a second valid subarray ending right here. Finally, at index 4, we hit a 7. This breaks our boundary constraints entirely. We immediately lock our bad idx to 4. Because this out-of-bounds element sits to the right of our valid targets, our formula drops below 0, correctly preventing any invalid arrays from being recorded. With our array completely traversed, our loop terminates cleanly. We return our final verified count of 2 fixed-bound subarrays. Let n be the length of nums. Time is big O of n, one left-to-right pass with constant work at each index to refresh 3 trackers and add valid starters. Space is big O of 1, only bad IDX, min IDX, max IDX, and the running total are stored. Function count subarrays takes nums, minc, and max k. Bad IDX tracks the last out-of-bounds position, starting at -1. Min IDX tracks the last index where we saw minc. Max IDX tracks the last index where we saw max k. Total accumulates the answer, starting at 0. Loop I across every index in nums. Read V as the current array value. If V is outside the closed range minc to max k, set bad IDX to I. If V equals minc, refresh min IDX to I. If V equals max k, refresh max IDX to I. Valid is the minimum of min IDX and max IDX minus bad IDX. If valid is positive, add it to total. Return total.